We're going to continue our work with word problems, and you should have watched two videos, one on coin word problems and another one on word problems involving finding number of tickets that were sold. And you notice that we were using a table that looks like this one here. Today we're going to talk about mixture word problems, and these are word problems in which you're mixing two types of quantities together to make a new mixture. Usually what it is you've got a more expensive quantity and you're mixing it with a slightly less expensive quantity to make a quantity that is priced someplace in between. Let's take a look at the first example, which is this one. It says Becca wants to mix fruit juice and soda to make a punch. She can buy fruit juice for $3 a gallon and soda for $4 a gallon. If she wants to make 28 gallons of punch at a cost of $3.25 a gallon, how many gallons of fruit juice and how many gallons of soda should she buy? So notice again, she's got two quantities. One has to do with fruit juice and one has to do with soda. The fruit juice is $3 a gallon, whereas the soda is more expensive at $4 a gallon. And the punch, when she mixes those two items together, will have a cost in between those two at $3.25 a gallon. And so what are we asked to find? Remember, we always want to check for that. What are we asked to find? Well, we are asked to find how many gallons of fruit juice and how many gallons of soda she should buy. So our first step is that we're going to go ahead and define those variables, as you know, and let's let X be the number of gallons of fruit juice that Becca is buying. So that's very clearly defined with a lot of detail, the way that we've been training ourselves to do in our problems. Now, because we're doing this problem with only one variable, and we've decided that X is going to represent the number of gallons of fruit juice, we need to find a relationship between X and the gallons of soda, right? So we need to be able to define how many gallons of soda are going to be bought. Just like in our previous video where we talked about selling a number of tickets total, and we did a bit of subtracting to define one type of ticket, we're going to do the same thing here. So we know that total, the punch is going to be 28 gallons. So X of that, X gallons will represent the fruit juice. So then that means that 28 minus X will represent the number of gallons of soda that Becca will buy. So again, you knew the total was 28 gallons, fruit juice added to soda. If X amount of that is fruit juice, then subtract that away from the 28 minus X to represent the number of gallons of soda. So let's come over here to our table. Okay, we're going to fill in the table. We have soda, juice, and we're making punch. So I'm actually going to put another label here. And the number here will be gallons, right? This is number of gallons of each. So juice is our X, and soda was 28 minus X. And then how many gallons of punch are we going to make? 28. So notice how now I'm going to put in the amount of gallons of punch here in our table, right? Okay, the value. So what is the cost per gallon? So this value is cost per gallon. That's what the value is. For soda, that's $4. And for juice, that's $3. And for the punch, ultimately, that will be $3.25. So that's the value per gallon. Okay. And what we're going to do to set up the equation again is to multiply, use this table to multiply across. So we've got, I'm going to put the 4 in front, and then the quantity is going to go in the parentheses. And then here for the juice, I have 3 times X. And then for the punch, I have 28 times 3.25. So notice how we multiplied across in our table. That table is really handy, isn't it? It keeps everything organized so that we can come up with the equation. All right, so our equation will be, let me rewrite it right here so we can solve it. 4 times 28 minus X plus 3X equals 28 times 3.25. Okay, so let's do some simplifying now. So we're definitely going to need some distributive property, aren't we? And the calculator may be over here on the right hand side with this decimal. So we've got 112 minus 4x plus 3x equals 91. And then we've got some like terms here that we can combine. And now let's subtract the 112. Now when you do that, be careful here. See that negative coefficient in the x? Don't lose that, okay? And so over here we have negative 21. And dividing both sides by negative 1, we get that x equals 21. So what did we just find, class? What did we just find? Okay, so remember, x was the number of gallons of juice. So Becca's buying 21 gallons of juice. Okay, so then how much soda did she add if she ended up with 28 gallons total? So we've just found that this was 21. I'm back to here to the table. So then this must be 7. So 7 gallons of soda. And we're going to check that because then these values should match up, right? So I'm going to multiply 7 times 4. See that here? I'm over here. So 7 times 4 plus 21 times 3. And see if that gives me the 91 that we got for multiplying 28 times 3.25. So that's 28 plus 63. And yep, that's 91. So that checks. So in conclusion, Becca bought 21 gallons of juice and 7 gallons of soda. Okay, we're going on to the next problem. Oh, let's read this one. So it says, Mark is making 12 pounds of nut mixture with macadamia nuts and almonds. Macadamia nuts cost $9 per pound and almonds cost $5.25 per pound. How many pounds of macadamia nuts and how many pounds of almonds should Mark use for the mixture to cost $6.50 per pound to make? Okay, here's what I'm going to do. I'm going to ask you to pause your video and use the previous example that you have in your notes. That's number 5, right? The one with Becca. See how far you can get on this solution to number 6. And then when you unpause your video, check your answer with mine and let's talk about it. Okay, so pause your video now. Okay, so here is my solution. First of all, check yours along mine and see if you have these in yours. Did you define your variables? Now, I let x be the number of pounds of macadamia nuts in the mix, but you might have let x be the number of pounds of almonds in the mix. That's okay, because even though your equation will be slightly different than mine, the final answer should be the same, okay? And the setup should be similar. So x is the number of pounds of macadamia nuts, which means that 12 minus x is the number of pounds of almonds, given that Mark was making 12 pounds of mix, right? Okay, so here's our table. X, and these are the pounds. This is the number here is measuring the quantity in pounds. And the value is the cost per pound. Cost per pound. Okay, so macadamia nuts, X of those at $9 a pound. So the total value that we bought, this is what it cost him to buy the nuts, is 9 times X. Okay, the almonds are 12 minus X in pounds. And we're going to multiply that by the value, which is $5.25 per pound. And that's going to give us the total value spent on almonds. And then here's the mix. So the mix is total of 12 pounds. It costs $6.50 per pound in the mix. And we multiply for the total value of the mix. So the equation then should look like this. 9x plus 5.25 times 12 minus x equals 12 times 6.5. So see, did you get that? How'd you do with that? Okay, so then notice how here I'm going to ahead and distribute it. And I've got some like terms. The 9x with the negative 5.25x gives me a 3.75x. And then I went ahead and subtracted 63. So we got 3.75x equals 15. And dividing, I ended up with x equals 4 pounds of macadamia nuts. And then that told me that this x here was 4. So the almonds there must be 8 pounds of almonds. And I went ahead and checked here 4 times 9 plus 8 times 5.25 to see if it would give me the $78 over here that I, in my original equation, right? We had a $78 here. And sure enough, when I multiplied those checks. So, in conclusion, did you write the conclusion statement? Here it is. Mark used 4 pounds of macadamias and 8 pounds of almonds to create his nut mixture.